Red Pill Philosophy uploaded a video entitled "Why Can I See That Lighthouse?" An informal flat Earth experiment. And this video is something which, I've been a follower of Red Pill Philosophy for years, and it's one in a long line of videos he does where he actually does the research, the legwork himself. No matter what side of this issue you are on, most people, when it comes to these topics, they don't do their own research. They don't do prima facie research. He actually did. And it doesn't matter whether you agree with his conclusions or not. What's important is that he actually did the work. And that's how you come to reasonable, rational conclusions, is by actually doing the research. And he physically did. And I applaud his efforts in that way, and I wish more people would do that when they talk about topics like this. But his question about why can he see that lighthouse, I think, to me, a better question would be, why can you see as much of the lighthouse as you can? I don't think it's in dispute that you should be able to see some of the lighthouse if the Earth is curved, but why can you see so much of it? And I'm going to use his numbers. I'm not going to dispute his numbers. I'm not going to, he went to a website that gave him, here's how much you should be able to see, etc. And with the information he gathered from 13.8 miles away, you, on a 95-foot tall lighthouse, should have a big chunk of it obscured. I think it was 77 feet of it should be obscured. Now that is, of course, not taking into account atmospheric anomalies like refractions, and there's all sorts of weird things that happen on the horizon where things are magnified, or you can see things below the horizon based on the way the atmosphere refracts light and all that. But I'm not going to even go into that. I don't know what the atmospheric conditions were then, so I can't really discuss that. But I think we can find out why you could see as much of the lighthouse as you can. And again, I'm not going to dispute any of his numbers. I'll use his numbers as he presents them. At about the 5-minute and 30-second mark in the video, he has he's blown up the image on the left, which is what he can see of the lighthouse. And on the right, he's got an image of the lighthouse taken from a much closer, maybe a couple hundred yards away. And so what I want to do is look at these images and see what is it we're actually looking at, and compare this stuff and see what we can, if we can answer the question of why he can see as much as he actually can. So to do that, let's look at these images in my graphic software and some things you can do yourself. The first thing we're going to do is we're going to take the image on the left, which is the blown up version that he saw through his binoculars, and we're going to take that and cut it out of the image, and we're going to do a very simple modification on that. I'm going to change the contrast on the image so that we can see the outlines of what we're looking at. I'm barely moving the contrast. Okay, we're just to see where the sides of the lighthouse begin and where they end. And the next thing we're going to do, and you'll see why this is important in a moment, is I'm going to take the image of the lighthouse itself, and we're going to look at a couple features of it, the image taken at much closer up. With the image much closer up, you can see there's a walkway around the very top part. Now that walkway, you can see a slight curvature to it. That's because whoever took the photo is standing below it, and so you can see from below the walkway has a curvature to it. Now, the farther below the image you were, or the farther below the lighthouse you were, or like if you were looking directly straight up at that lighthouse, that's what you'd see below. You'd see just a round walkway. Now, the closer you are to the horizon or flat with it, the more it would end up looking like this. So what I've done is I've taken and made a rectangular image here with a slight curve at the top. and it goes to the corner of both sides of the walkway where the walkway connects with the top of the lighthouse. So these proportions taken very close to the lighthouse. Then let's now take these proportions and let's look back at this image, which is the image taken from 13 miles away through binoculars. Let's now take this image that all we did was change the contrast on that image. It's all that we did, change the contrast. I've not manipulated it in any way. The first thing you'll note is the curvature underneath the walkway, which this is the angle it was when you were basically a couple hundred yards away looking straight on at it. That curvature now is radically different. All right, so that curvature, which was more flattened, now looks like that. So the curvature alone from underneath that walkway suggests that you're looking from underneath. You're looking from more below. You're not looking, which is what you would expect if the Earth, if there was a curvature to the Earth, then it would not be standing straight up as the Earth, as it was moving, the Earth was curving. You would be able to see more up below, and that's exactly what you get here. You see that the dark at the top is the walkway, and now the curvature, which again, the more round it is, that means the more from below you're looking at it. So the curvature tells us that we're probably looking at something which is now pointed away from us, which is what you would expect if it was moving below the horizon. Now the next thing we need to do is we're going to take the image itself, and I'm going to make this transparent so we can see through it as I do what I do next. So now we're going to take and we're going to make the width of that of the lighthouse image from the binoculars. It's got to be the same width as what we see in the close-up picture. In other words, the proportions have got to be the same. So when you shrink that down to where the proportions are the same, then you see that you lose all of this down below in height. Okay, so what we can see from the lighthouse from that angle is a large portion. You can't see what's down below all the way down. You're missing all of this. And based on refraction and who knows what the atmosphere was like that day and what the elevation of the binoculars were and all of that tells me that somewhere in there you could figure out exactly how much you'd be able to see given all of that information. But in any case, it certainly looks to me like the video that Red Pill Philosophy uploaded shows an image of what you would expect. Looking up at something, leaning away from you, and only a small portion of that, and that indicates to me that you are looking at something which is below the horizon. Anyway, that's my take on it. I again applaud Red Pill Philosophy for doing the research himself to get this conversation started. Thanks for watching.